we look at exponential functions, and exponential functions are the form a times b to the x. Remember that x is an exponent here. That's what makes it exponential, is your variable is going to be the exponent. A does not equal 0, and b has to be positive, so greater than 0. We call a the initial value when x equals 0. That's how you get the initial or the starting value, and then b is the base. Okay, and then we look at exponential decay and exponential growth, depending on what the b value is. So we want you to sketch a graph of f of x equals 2 to the x and its inverse. And remember, for inverse functions, you switch the x and y points. So take a minute and do that. You can pause the video. In your calculator, you're going to enter 2 to the x by doing 2, and then the caret button here above the division symbol, that's the exponent key, and then your variable x. So when you graph it, it looks something like that. It looks like the graph is just starting right here, but remember, if you trace it, as you go to the left, notice we have values here. So I'm almost at -10, and I'm getting very close to 0 here for the y value. Okay, so see if you can sketch that graph and its inverse, and then when we look at the limit questions. So here's the answer key for the graph and the table. Nothing too crazy. You get the inverse by switching the x and y values. So for example, 3, 8 was on the original. That was the point up here. So on the inverse, we have 8, 3, which is this point here. The next questions will deal with limits. So remember, the limit as x approaches -infinity of f of x. That's saying as you go way out to the left, what is your y value approaching? And we saw in the graph, as you go way out to the left, the y value is approaching 0. And then for the other limit questions, pause the video if you need to. I'm going to show you the answers. And I also put the other notation you can use. As x approaches -infinity, the y value approaches 0. And you can see it's similar for the others. Okay, the domain and range of the function and its inverse. Again, if you want to pause the video and try this, I'm going to show the answers. The domain of your original function, y equals 2 to the x, is -infinity to +infinity. So you can put whatever you want in for x. And then the range, the lowest y goes to 0 but never touches. You have an asymptote there, a horizontal asymptote. And then for the inverse, your new domain was your old range. Because remember, all you're doing for the inverse is switching the x and y values. And then your new range for the inverse is your old domain values. So the equation of the inverse, you switch x and y. So instead of y equals 2 to the x, you have x equals 2 to the y. And what we're going to get into in the next couple of videos is, how do you get y equals? We have 2 to the y, where y is an exponent. So this is a new kind of function for us. We can't just divide by 2 to solve, so there's going to be a new function that we can use. The next two questions are very straightforward, just doing some evaluations. So I suggest you pause the video and try those, and I'll show you the answers. Okay, so there's the solutions. And what I want to point out is order of operations. Make sure that you do the exponent first, and then multiply by 4 in this case. And then in number 3, the y-intercept always occurs when x equals 0. So all you're doing is putting 0 in. So if you look at, just say the last one, 2.4 to the 0 is 1, because any non-zero raised to the 0 will be 1. Times 3 will give you 3. Subtract 5 will give you -2. So the y-intercept is at 0, -2. Going on to the next part. We're given a population of Springfield in 2010 was 274,000 people, and then it increased to 312,500 in 2018. It tells you the population grew exponentially. So we're going to use basically those 2 points to write an exponential function that satisfies the situation. So the idea is we know that we have an exponential function y equals a times b to the t, and we know the starting value is 274,000. So we know that that's our equation. Y equals 274,000 times b to the t. Okay, now the idea is we have 3 variables. We have y, we have b, and we have t. The other point that we're given was in 2018, we knew the population was 312,500. So we know a t and a y value. So our t value, representing the year 2018, we have 8 years since 2010. Okay, it tells you t is the number of years since 2010. So we're going to put in a t value of 8 and a y value of 312,500. Okay, then you go ahead and solve that. Divide by 274,000, and then to get rid of the exponent of 8, we're solving for the base. So to get rid of an exponent, you raise both sides to the reciprocal exponent. And that gives you b equals 1.01657. Essentially what that's saying is you have a 1.657% growth rate. Okay, so there's our equation. So assuming the growth continues, the population in the year 2025, well, we know that's a t value of 15. So substitute 15 into your function that we just came up with. And that gives us, if we use just this rounded value, that gives us this value here, the 350,598. If you use the exact value, so if when you did this 8th root, or raise it to the 1/8 exponent in your calculator, there are a few more decimal places here. If you use that, you end up with 350,600 people. So you end up with 2 more people because of the rounding.